In this video, we are going to learn the so-called rational roots theorem. So we use the rational roots theorem to find rational roots of a polynomial. So we're going to say use to find rational roots. Rational roots, or that means zeros. Rational roots, or in other words, zeros of a polynomial with integer coefficients. Integer coefficients. So if the coefficients are not integers, so we use to find rational roots of a polynomial with integer coefficients. So the coefficients are not integers. What we can do, we can multiply by the least common multiple and get integer coefficients. So we can do that. But in the theory, we say it like this. So even we can handle other rational coefficients because we can multiply by the uh, least common multiple. So let's write it. The coefficients if the coefficients are fractions, if the coefficients are fractions, are multiplied by the least common multiple of denominators. Denominators to get a polynomial with integer coefficients. So we can do that because the goal is to solve a equation which has a polynomial in it. So that's the whole point. So that you can always divide and multiply by numbers. But if you just have a polynomial, what we can do, we can pull the factor out and just consider the integer polynomial part. So we can do that. So let's write the theorem. So what it says, the rational roots theorem. So it says if x equal p over q with no common factors, or what sometimes we say in least terms, with no common factors. If x equal p over q is a root of the polynomial fx equal an xn plus, like that, the last term is a naught. So we are interested in the first and the last term, where ai are integers. Okay, are integers, important. So what it says that then the p has to divide a naught and q has to divide an. So that's what the rational roots theorem says. So it says that if you know any rational root which you can write in the p over q form, then p has to divide a naught and q has to divide an, because this can help you, because it's going to give you all the options for possible rational roots. Okay, so give possible rational roots. So unfortunately, it cannot give you the other like irrational roots. For them, you have to use some other techniques. This only give all the possible rational roots. But after you know the rational roots, then you can divide and get like a smaller polynomial and you can solve it. So that's how we kind of do it. Since this is like an interesting result, let's look at how we prove um, the result. So the proof, this is how it works. So let's say if x equal p over q is again no common terms, so it's important, very important. So with let's say with let's say without uh, common terms, common factors, without common factors, if x is a root, then we know that f p over q has to be 0. So let's plug in. So by substituting, we can write a n p over q, that's x to the nth power, like that, a n minus 1 p over q n minus 1, like that. So let's write the last two terms also. So it is a1 p over q plus a naught equals 0. Now what I'm going to do, I'm going to write both sides by q to the n. So if I write both sides by q to the n and factor p from the first n terms, I can move the a naught to the other side because it doesn't have a p term. So but all the other terms has a p. So what we can do, we can take that out and then also multiply everything by qn. So once you do that, you're going to get a n p to the n minus 1, like that. And then here you have a n minus 1 because you multiply by qn, so you're going to get p to the n minus 2 and a q, like that. And then if you look at the these terms, you're going to get a 1 and then you have q n minus 1. On the other side, you have minus a naught because you move that to the other side, and then also qn. Now the interesting part, then you can see that on the left side, these are all integers. So you can see that the left side is divisible by p. So then that means that since those two numbers are equal, the right side also should be divisible by p. But we know that p and q does not have common factors. So even it raised to the power is still no common factors. So the only possibility is p divides a naught. So it's very clear. So we can see that this implies p divides a naught since p and q do not have common factors. Okay, so we can use a similar argument to rearrange. So what we can do next? So we're gonna multiply by q, and so now we have that. And then what we can do is we can isolate a and p n on this side, only the first term, and move everything else to the other side, because once you do that, you can see that all the other terms on the other side have a q. So we're going to use a very similar argument, but you leave the first term and move everything else to the other side and make a similar argument. So we can say similarly, uh, we can say writing a n p n, and on the other side we can see they all have a negative sign, we can have a n minus 1, p n minus 1, and the other terms, and the last term is a naught q n minus 1. We can pull q out. Now you can see the same argument because p and q are integers, so that's how we can do it. So same argument because q divides the right hand side now, and then that means q has divided the left hand side as well, but p and q doesn't have common factors, so this implies that q divides a. So it's a very simple argument. Okay, now let's see how we can apply this in a problem. So we can do two problems just to make sure that we understand the argument. So first problem. So let's say use the rational roots theorem, rational roots theorem to factor and solve. So we can do both. Solve this equation 2x to the fifth plus x to the fourth minus 6x to the cube plus 4x minus 1 equals 0. And you can see that this is a degree 5 polynomial, or what we call quintic. So there's a theory in mathematics. It says that if you have a general quintic or higher order equations, there are no formulas to solve. You cannot find a formula for that. So that means this is order 5 polynomial, but still we can use the rational roots theorem to solve this problem. So that's the benefit of this. So what we can do, so let's see the complete argument. So we can say let fx equal 2x to the fifth plus x to the fourth minus 6x to the cube plus 4x minus 1. So we pick the polynomial, and then we can assume the roots. So if x equal p over q, again no common factors, or in lowest terms we can say that's the other way to say it. If x equal q is a root, is a rational root, in lowest terms means no factors. In lowest terms, then we know that p has to divide the constant term and q has to divide the leading term. So these can give you options for p and q. So what are the options for p and q? So that means p has to be, those options are, because if it divides -1, the only options are plus or minus 1. Because it has to divide -1, that means these are the factors of p. These are the possibilities of p, plus or minus 1. There are no other options because it cannot be 2. And options for q are factors of 2. So again, plus or minus comes automatically, and since there are 2, plus or minus 2 is also there. So those are the possibilities of q. Now what we can do, we can write the possibilities of p over q. So what are the possibilities of p over q? You can consider all possibilities. So start with the easy ones. So if you start with p 1, q 1, so you get 1. If you get opposite sign, you get -1. So that means the p over q also have plus or minus. So this is always there, plus or minus 1 always there. It's always a fact. Now think of p plus or minus and q plus or minus 2, but it is in the denominator, so that means the only options are plus or minus 1/2. So these are the only possible rational roots. If there is a rational root, it has to be one of them. So there are only 4 options. So that means kind of tell you that there should be some irrational roots or complex, because it's order 5 polynomial. So we kind of know beforehand. So let's write this. So that means, so these are the only options. These are the only options only possible rational roots. So it doesn't mean that there are no more, there can be irrational roots, but that we can find from this argument. Now what we can do after that, we can use either factor theorem or long division or synthetic division to find to continue. So we can see what we can do. So now what we can do, use the factor theorem, and if you don't know the factor theorem, you can find that in the other video. Use the factor theorem or the long division or synthetic division to find other factors. So what we gonna do, we're gonna use the factor theorem or the synthetic division. Normally what we use the synthetic division is much easier because we know that by the factor theorem, if you plug in a value, if you get 0, that means you can find a factor from that. That's what the factor theorem says. You plug in a value, you get a 0. Like let's say you plug in 1, let's say you get a 0. That means x minus 1 is a factor. And then what we can do, we can do the long division to find the quotient and then work with the quotient. This is smaller degree, so that means you can go one by one down. So let's see how it completely works. So what we can do is we can use a synthetic division now. So let's do that. So we use synthetic division. And if you forget what is synthetic division, you can see that in the other video. So we can use synthetic division. So how to use synthetic division? We can write the coefficient first and make sure that you have all the degrees. If there's a degree missing, you have to put a 0 in there. And you can see that that's exactly the case here. If you look at the polynomial, there's no x squared term. That means you have to put a 0 for that. So that means we can put the coefficients. So it is 2, 1, -6. There's no x squared term, you put a 0, and the 4 and -1. That's what you get. And then we first check whether 1 is a 0 or x minus 1 is a factor. So let's put it there. Now what we can do, we're going to copy the 2 down here and then first multiply and add. That's how the synthetic division works. Multiply and add here. So when you multiply, you get 2. So when you add, you get 3. Now you can again start with 3. So you multiply 1 with 3 and add here. So it is 3. So when you add, you get -3. And then when you multiply, you get -3 and add here. So you get -3. Multiply, you get -3. When you add, you get 1. Now when you multiply, you get 1. When you add, you get 0. So that is good. That means 0 means x minus 1 is a factor, or 1 is a 0, or 1 is a root. Okay, so you can write this in several ways. So that means x minus 1 is a factor, or the same thing you can say that x equal 1 is a root or a 0. Good. So we're gonna continue. So now we're gonna use the new one because it's much simpler than the original one. So let's see whether it's always a good idea to check whether 1 is again a double root. What's a double root means? It's a root again. So let's check whether that's the case. It's always a good practice. Check 1 again because it's easy to work with. So let's do that again. The same process. So we're gonna copy 2 down here and then multiply. So 1 times 2 is 2. Add, you get 5. 1 times 5 is 5. You add, you get 2. 1 times 2 is 2. So you put it there. So -1. And 1 times -1 is -1. And you can see that you get 0 again. That means x minus 1 is a factor again of the new polynomial. Is a factor. So that means a double factor of the original one. Now let's check whether it's a good idea to check whether 1 is a factor again. So because we don't know, so let's check that. So we're going to check whether 1 is a factor again. So copy 2 down, and then you're gonna get 2, add 7, and then it is 7, add 9, and then 9, you get 8. This is not equal to 0, so that means it is not. So that means 1 is not a factor again. It's not a triple factor, it's only double factor. So that means let's go to the next number. What's the next number? Let's check whether negative 1 is a factor, because we always work with the easy numbers first. So let's copy the original one again. It is 2, 5, 2, negative 1. That's what we work with. So let's check whether negative 1 is a factor. Negative 1 is a root. So copy. So what do you get? 2. You just copy the first number. We don't do anything with that number. Just copy. Good. So we copy it here, copy it there. Good. So and then you're gonna get negative 2. When you multiply, you get negative 2, and add, you get 3. And then multiply, you get negative 3, add negative 1. When you multiply, you get 1, you get 0. Good. That means x minus minus 1, in other words x plus 1, is a factor. So we get 3 factors already, and then we know what is the remainder. What is the quotient? So the quotient is, there are 3 terms. That means the quotient has to be 2x squared plus 3x minus 1. So now what you can do is, we know that the half, we have half here, plus or minus half. That's the only other possibility. We can check that. Or since this is quadratic, we don't need anything else. This is just a quadratic, so we can use all the quadratic equation. So that's the kind of way to do it. So let's see how the rest of the work follows. So we can write, so thus the factors, it is 2x to the 5th plus x to the 4th power minus 6x cubed plus 4x minus 1. Now we know that x minus 1 is a double factor, because 1 works twice, and then x plus 1 was the other one, and we had the quotient as 2x squared, because those are the coefficients coming from the coefficients, because those are the numbers we get 2, 3, negative 1. That means corresponds to this. Now what we can do, we can say this equal to 0 if you want to solve it. So the next step is, because since we already know the zeros of the first 3, what we can do is we only solve this one. So that's the next step. So we're going to say solve solve 2x squared plus 3x minus 1 equals 0. For that, we can use the quadratic formula. So by the quadratic formula, if your zeros are alpha beta, then we can write this one as negative b plus or minus b squared minus 4ac square root over 2a. So let's plug in. So 3 equal b, so it's a negative 3 plus or minus b squared means 9 minus 4, a equal 2, c equal negative 1. So take the square root divided by 2 times a. So if you simplify this one, you're going to get negative 3, and then plus or minus, we have negative, negative, positive. 4 times 2 means 8, so you're going to get 17 square root divided by 4. We can split this. We can write this one as 3 over 4 plus or minus square root 17 over 4. This will be useful later when you write the factored form. Okay, so that means we know all the solutions. Now what we can do, we can consider each factor. Set each factor equal to 0, because we already know those two, and from the other one we can solve. So we can say, so then what we can do, we can set x minus 1 squared equal to 0, and x plus 1 equal to 0. So those two are going to give you two other values. So this says that x equal 1 twice and x equal -1. So those are the other zeros. So that means the solutions are x equal 1, 1, there are 2 and then -1, and then we have -3/4 plus or minus square root 17/4. So this is how you use the rational roots theorem to solve a quintic, that means order 5 polynomial completely. So we first find the rational roots and then we get the quadratic and then we solve the quadratic equation. Now the question is how to write the factored form. So let's work on that to find the factored form. So what we're gonna do, we're gonna start with the first equation here. So we have now to find factors, to find factored version, what we can do, we can start with the same equation. So 2x to the 5th plus x to the 4th minus 6x cubed plus 4x minus 1 equal. So what we have, we already know it is x minus 1 is squared, x plus 1, and then the third factor is coming from the coefficient, it is 2x squared plus 3x minus 1. So what we want to do is we want to write the last one in the x minus alpha x minus beta form without the 2. So what we're going to do, we're going to take the 2 out as a factor. So that means we can write this one as 2 times x minus 1 squared x plus 1, and we divide each term by 2. So it is x squared plus 3 half x minus 1 half. That's what we get. Now since we know the alpha and beta, the two factors, we can write this one like this. It is 2 x minus 1 squared x plus 1, and then this is simply x minus alpha, and x minus beta, we already know what is alpha and beta because we solved the quadratic equation. So we just plug in there. So that means we can write this one as 2 times x minus 1 squared x plus 1, and then here we're going to subtract. We know that alpha and beta are -3/4 plus or minus square root 17/4. So just pick one. So let's pick the negative one first. Since the negative sign is going to change the sign, so that means this is simply x plus 3/4 plus square root 17/4. That's the first one. The second one is x plus 3/4. If you go with the plus sign, it changes the sign to become minus square root 17/4. So that is the complete factored form of the quintic. So let's do another problem just to see how things work. So that's the next one. So let's say example solve. Let's do this order 4 polynomial. So 6x to the 4th plus 23x cubed plus 12x squared minus 27x minus 14 equals 0. So we're going to solve this quadratic equations. Order 4. Order 4 is quadratic. So this is a quadratic equation. The other one is what we call quintic equation. So we can use the rational roots theorem. So say if, so the answer, if P over Q is a rational root, again with no common terms, then we know that P has to divide -14 and Q has to divide 6. So that means we're going to look at factors. So that means P, the possibilities are the factors of a -14 plus or minus 1 plus or minus 2 plus or minus 7 and also plus or minus 14. So those are the options for P. and then options for q are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Now what we can do, we can write the possible cases. So we're gonna pick one of P and then consider all the cases of Q. Next one, all the cases of Q. So that means there are 16 possible cases here because there are 4 times 4. But there are some common ones, so you can remove. For example, if you get plus or minus 1, and the P has plus or minus 2, and Q also has plus or minus 2, but when you divide, it's gonna be plus or minus 1. So that means you don't need that. So there are cases like that. It's gonna it doesn't appear. These are degenerate cases. So let's write the possibilities of P over Q. So let's write P over Q. I'm going to start here because there are a lot of cases. So I'm going to start with the plus or minus 1, plus or minus 1. That's going to give you a plus or minus 1. And then go to the next one. I'm going to go to the second option of P with the first option of Q. So that means you're going to get plus or minus 2. That's the second option. You get plus or minus 2. That's for the second option. So keep doing. And then if you go to the next one, you get plus or minus 7 and plus or minus 14. So you're done with the first option. Now we do the same 3 with the second option of Q. So we're going to go to the second option of Q. So let's do that and ignore the common ones. So if you go with plus or minus 1 of P and plus or minus 2, so that you're going to get plus or minus 1/2. See that? And then the next one, you get plus or minus 2, plus or minus 2 is the plus or minus 1, so we don't write it because it's already there. Go to the next one. So you get plus or minus 7/2. And then if you go with the 14, you can see the plus or minus 7 is already there, so we don't write it. Now go to the next number. If you go to the next number, it's plus or minus 3 of Q, so that means it is plus or minus 1/3. And then plus or minus 2/3. And then plus or minus 7/3. And then plus or minus 14/3, like that. And then go to the last one. So it's going to give you plus or minus 1/6. And then the next one, if you divide plus or minus 2 with plus or minus 6, it is plus or minus 1/3 is already there. So we don't write it. It's right here. So we don't write that. And then the next one is plus or minus 7/6. And the last one is, you can see 14 over 16, which has common factors. If you remove the common factor, what's going to happen? It is 7/3. So 7/3 already there, so that means you don't write it. So these are the only possible cases. These are the only possible rational roots. Now the question is, which one we're going to try? We're going to try only the easy ones. So we can try this always. We can try that. And maybe this, because this is order 4 polynomial, so that means if you are lucky enough and find 2, that will be enough, because after that you can divide and then you get a quadratic and you can solve. So we probably try those 2 and maybe this one. But that's another easy one. So those are the only options that we normally try. And also try 0, but it's very clear that 0 is not a factor here because there's a constant term. So we only try the first 4 actually. So let's do that and see how it gonna work. So again we use the rational roots theorem. No, we can use this rational roots theorem. We can use synthetic division. So let's do that. So use synthetic division. Use synthetic division. So if using the division, again we always start with the easy ones. So let's say so let's try the numbers and check whether you have all the terms. So you can see nothing is missing. You have degree 4, 3, 2, 1, 0. So it's good. So we can write the coefficients. So it is 6, and we have 23, 12, and then negative 27 and negative 14. Those are the coefficients. First we check whether 1 is a 0. So as we did before, we copy 6 down here and then multiply. So it is 6 add 29 and then multiply 29 add here. So you're gonna get 41 and then multiply add here. So you're gonna get 14, and then when you multiply 14 add here, you're gonna get 0. Very good. That means x minus 1 is a factor. Okay, so x minus 1 is a factor. So always it's a good idea to check whether 1 is a factor again, because that's easy to work with. Otherwise you're gonna miss that. So let's do that again. So we copy 6 down and then 6 and then add, you get 35. So you 35 add, you get 76, and then 76 you add here. It's very clear that this is not equal to 0. That means x minus 1 is not a double factor. Okay, this implies that x minus 1 is squared is not a factor. Okay, because that doesn't work. So we're gonna go with the next number. So let's see the next number. What's the next easy number? -1. So let's go back to the number. So it is 6, 29. That's the one. We don't want to go to the original one because we already know one factor. Always start with the simpler version. 14. So we're going to check whether -1 is a factor. So copy here, multiply. So it is -6. Add, you get 23, and then multiply -23, you get 18, multiply, you get -18, you get -4, which is not equal to 0. That means x plus 1 is not a factor. It's not a factor. So that means it didn't work. So let's go to the next number. What's the next number? 2. So let's go with 2. So it is 6, 29, 41, 14. So we go with 2, copy, and then do it again. So it is 12. So you get 41, and then 82. You get 1, 2, 3, and then multiply. You get 246. It's very clear that it's not going to work. So, but I'm writing everything. So that means nope. So that means x minus 2 is not a factor. So let's try one more. What's the last one we can try? -2 maybe. So let's do that. So 6, 29, 41, 14. So go with -2. Yeah, so 6, copy here. You get -12. When you add, you get 17. And multiply, you get -34. When you add, you get 7. When you multiply -14, you can see it worked. So it's 0. So that means x plus 2 is a factor. So that's good enough because we only need 2 factors. We already know x minus 1 is a factor. Now we know x plus 2 is a factor. So that means the other term is 6x squared plus 17x plus 7. So we can use that and we can solve. So that's a quadratic. So we can solve. So let's do that. So that means in this step, because since we get a quadratic, we're going to stop checking the factors. So we're going to go back and write. So we can see that. So we can say so we have 6x to the fourth plus 23x cubed plus 12x squared minus 27x minus 14 equal, we know that one is x minus 1, the other one is x plus 2, the third one is 6x squared plus 17x plus 7. Now what we're going to do, we're going to see whether we can factor this. Are there easy factors? How to check whether there are factors? So we multiply the two. So if you don't know how to do that, look at the quadratic equation video. We're gonna discuss like how to solve these kind of things. So we normally multiply these two numbers. So we have 6 times 7. That means 42. So the goal is to so I'm gonna write it here because I need a little bit more space. So the what we can do, we can multiply those two numbers. So 6 times 7, which is 42. Now what we can do, we're going to break 42 so that the sum of the numbers, sum of the factors is 17. So can you think of two numbers, when you multiply you get 42, when you add you get 17, and you can see that those two numbers are 14 and 3. So after you figure out those two numbers, now you're going to think of what is the pattern of the factors. um, so you can see that. So I'm going to write it here just to tell you like how it really works. So this is what we have. Now 6 has more factors. 6 has 6 times 1 and 2 times 3. So we don't know which one. Now the problem is, let's say you have 6x and x like that. So your goal is to put the factors of 7 on the other side. But the problem is 6 doesn't divide any of those two numbers. So that means this is not a possibility. So if you need to know more about that, look at the quadratic equation video. I explained that there. So that means this doesn't work. So that means your only option has to be 3x and 2x, because those two factors 2 and 3 are going to divide one of them. Okay, so now what we're going to do, so let's start with the 14. So that means 14 divide 2, so that means this number goes here. So what goes there? So number goes there is simply 14 divided by 2. That's the number goes there. So that means this has to be plus 7. And the other number, we're going to make a similar argument to find the other number. What we're going to do, we're going to divide 3 by 3. That means plus 1 is the other number. That's it. Okay, so that's how you get the other numbers. So it worked. So those are completely factored. So that means we can write the factored form. So we have 6x to the fourth plus 23x cubed plus 12x squared minus 27x minus 14 equal, we have x minus 1, x plus 2, and then we have 2x plus 1 and 3x plus 7. What we're going to do, we're going to set this equal to 0. So that means, so then what's going to happen, you're going to set each one equal to 0, x minus 1 equal to 0, or x plus 2 equal to 0, or 2x plus 1 equal to 0, or finally 3x plus 7 equal to 0. So this can give you x equal 1, or x equal negative 2, or if you, how you do this, you move 1 to the other side first, so it's a negative 1, and divide by 2, so that means x equal negative 1/2. The same thing here, you move 3 to the other side first, so it becomes negative 7, and divide, so that means negative 7/3. So that means those are the solutions. So therefore the solutions of 6x to the fourth plus 23x to the cube plus 12x squared minus 27x minus 14 equals 0 are, you can see x, let's start with 1, comma negative 2 comma negative 1/2 and negative 7/3. So you can see that this is not easy to guess. You can't guess them. So what we did was we used the rational roots theorem first to find the possibilities, and then use a synthetic division to make it simpler at every time. And then finally we got these as answers. That's how we use the rational roots theorem to solve a polynomial equation.